Okay, welcome to part 6 of 2.2 bonding between atoms. We'll be looking at covalent bonding, and we'll be focusing on the first box in this table. So non-metallic atoms share electrons to form covalent bonds. I think we have already established that. And you need to be able to use electron dot diagrams. It's also called Lewis dot diagram. And structural formulae to show covalent bonds between non-metallic atoms. Okay, so let's look at that. So covalent bonds, as it was already established or has been introduced before, it's a bonding between non-metal atoms. We'll do role play in class and look at a few more examples. There is a list of covalent molecules that you must memorize. Or I should say, if you don't know those compounds, it's pretty embarrassing. It's almost like general knowledge. Atoms are held together by electrostatic attraction. It sounds like ion, but ions are not involved. If you have nucleus and nucleus, they're positively charged. And if you have got electron fixed, so they are still having electrostatic attraction to each other, and that's how non-metals are held. And they do that by sharing electrons. They share electrons in a way that allows all atoms to have full outer shell. So by sharing a bag with your friend, it feels like you already gained another one. So you've got, a bag on each arm and you're happy. Above diagram shows the two hydrogen atoms sharing one electron each. So by sharing one, each hydrogen atom feel like they've got two electrons, which should be the most stable configuration if you only have one electron shell. Fluorine has got 7 electrons in each of outermost shell. Now 7 is one step away from being 8, so it's eager to gain one electron. But if you are only in a community of just full of fluorine atoms only, fluorine atom and fluorine atom would decide to share one electron each, so that they can have 8 electrons each in the outermost shell. So by sharing it, they get octet. They achieve octet configuration. Now, electron dot diagram. It's also known as Lewis dot diagram. You'll be practicing that. It's used to show how electrons are shared in the molecule. If you're looking at covalent bonds, it's usually a molecule. Some of them are covalent lattice, but that's not many. Electrons in the outermost shell only are shown. Okay, you don't have to draw anything in the inner shells. Lone pair of electrons are not for bonding. Lone pairs of electrons are just pair of electrons, which also are called as non-bonding pair of electrons. You will see what I mean in the next slide. Non-paired electrons can form bonding. So just single electrons just sitting on its own. If you have 2 electrons, it's considered as bonding. If you have 2 electrons shared from each side, so 4 electrons involved, you would expect 2 bondings to occur. If 6, so 3 each, coming from each atom within a bond, then that's a triple bond. And they can be represented with 1 line for single, 2 lines like equal sign, that would be a double bond, and 3 lines, it would be triple. We'll watch the video later. In this diagram here, oops, not that, this one. You see single bond happening between oxygen and hydrogen. Oxygen to carbon. Do you see this carbon sharing 3 electrons, this carbon sharing 3 electrons? That makes 6, that will be triple bond. This carbon and this carbon, they're sharing 2 electrons each, so 4 electrons involved, and it's a double bond. If you count how many electrons there are for each carbon, you should still see 8 electrons only. So this carbon here, 6 here, and 2 on this side, so that makes up 8. this carbon again, 4 here, 2 and 2 surrounding this carbon. So that makes up 8 as well. Chlorine here, you can see that there are 1, 2, 3 lone pairs of electrons. They are just sitting there. The pair is stable enough. You don't have to use them for bonding. Only single non-bonding electron can form bonds like here. Okay? And once you got that dot diagram, then you convert it into lines, because so many dots wouldn't be really looking nice. That's clearer to have these lines only, but you still have to show lone pairs of electrons like this chlorine or oxygen here. All right. And that is how many electrons there are in the outermost shell for each element. Now we'll be dealing with or using this one. You are only using non-metals because we are working with covalent bonds only. So yeah, we kind of ignore the metal ones. You'll be only using like oxygen, fluorine, chlorine, sulfur, carbon, phosphorus. Yeah, those ones. All right, how do you draw Lewis dot diagram? It's in the textbook as well. So if you can learn how to do it, you don't have to copy this slide. But maybe you should pause the video and copy if you want to copy. But that's how you do it, and I'm going to explain that now anyway. So let's draw Lewis dot diagram. Okay, so 3 examples: CF4, CO2, and N2. Now firstly, what you have to do is to find which element that is involved has got the highest highest number of non-bonded electrons. So carbon has got 4 as its valency. F would have only 1 because it's group 7, so only 1 bonding can be formed with fluorine. Carbon needs to be the center. So I put C in the middle, and I put 4 electrons. I'm using cross because I wanted you to see the difference between electrons coming from C and F. By placing carbon in the middle and allowing fluorine atoms, which has got 1, 2, 3, 4, 5, 6, 7 electrons each, hopefully you can see that then there's a bonding happening. 2 electrons means bonding. Now this is not the finished answer because you have to use lines. And if you're asked to draw electron dot diagram or Lewis dot diagram, please make sure that you draw all the lone pairs of electrons, even though they are not used for bonding. They are important. When we start talking about shapes of molecules, it is important for you to know where those lone pairs of electrons are, because that would make difference in the polarity. Again, we'll talk about that in the next video. Second one, CO2. Carbon still has the highest number of electrons available for bonding. Oxygen would be next, so I put oxygen surrounding. Oxygen atom, each one of them have got 6 electrons. 1, 2, and 3, 4 electrons are not gonna be used for bonding, so it would only use 1 and 2 electrons. Now they might be on each side usually, but in this case, because carbon's on this side, I put both electrons on this side. And I did the same for the other oxygen here. Now what you can see is carbon here already has 4 and 2, 2, so 4 electrons are added. Carbon has now 8 electrons around it. Let's make these into lines because that's neater. Carbon in the center still. Because you are using 4 electrons, you can make a double bond to each side. Carbon doesn't have any more lone pairs of electrons, so you don't have to draw anything. But oxygen, you do. you need to make sure that around each oxygen you have 8 electrons. 1, 2, 3, 4 electrons are in double bond. 5, 6, 7, 8. And that happens the same. So 8 electrons are around each element here, each atom here. Nitrogen. Now, valence is 5 plus. But if you have got 5, 2 of them would be, I should just draw just one nitrogen. 2 of them would be non-bonding pair. That's not going to be used for pairing up with anything. So you would need to use these 3 only. The partner here is another nitrogen atom. You have got 3 hands and the partner has got 3 hands. So why don't you just match those up? So you would have 6 electrons within atoms. That makes, whoops, N triple bond N. That's nitrogen. It's harder to break compared to double or single bond. Therefore, nitrogen molecule N2 is very stable. So there it is. That's how you draw Lewis dot diagram. We'll watch the video later, and you can now do question 1 from page 71. All right, see you in part 7.